why it's so warm in here?
Why?
I haven't had my lamp on all day because we've been testing and I had the upper lights on. And therefore there was no heat source in that corner. And that corner thinks it's cold because the air circulation's terrible and that just becomes a pocket of...
That really is terrible.
So, hence why I have the fan, but now I can turn that, especially since I'm going straight at Gomer now.
No, I like it. You're good. It's hot in this room.
It is very hot.
It's only because you guys are in here.
Gunner, share with everybody.
Never.
Alright, so we need to cover 2 lessons today, and your homework is really TBD, and quite honestly, at this point in the year, I'm not that worried about collecting homework, but you should still be doing it because it's to your benefit. So, 10.2.2, 10.2.3, I'll choose some problems when we get to the end of the lesson, but TBD means to be determined. Yes, we're skipping sections. I want to try to cover some more stuff before we get to the end. So, we will dig deeper into parabolas after the test. You guys understand how to graph a parabola, you understand vertex form, you understand graph, you know all of that. You essentially know everything about parabolas that you need to know. We'll go a bit deeper after we get past the test. Today, there's some information that's probably going to be on the test that's really quite easy, but you need to have some experience with it before we get to the test so that you then know how to use it.
What's the date?
The date? 4/9. Hey, for real, no joke, if you have friends that are 16 or older, I thought it was 18, but if you have friends 16 or older that want a job at a rock wall, have them contact me. I need to hire people for real.
Oh, can I get hired?
Yeah, I would love to hire, like, high school girls. Young female climbers are what we need there to encourage the girls that come in at the gym. Because climbing is this, like, male-dominated sport, but, like, females, like, there are some amazing female climbers.
Yeah,
we gotta get more. They're better. Like, they're, well, the one issue they have is they're short, right? You're shorter than males most often, but you have a, yeah, you have a great body for climbing.
Yeah, no.
All right.
Basically, the calculators are at another school for testing.
You don't really need them.
Okay, I just
Like,
didn't know.
You're good. You're good.
I
We're
use
not
I'll
doing
send
that.
Owen.
As a source
Like
of
your security blanket?
Yes. it
All
is
right,
a security blanket.
So back in the 3rd century BC, right? Eratosthenes, which depending on who you ask, his name will be pronounced differently. Eratosthenes helped calculate the Earth's radius. Right now, we can't dig a hole to the middle of the Earth, and even if we could, your apparatus would melt before you got there. So we used some other information. So Eratosthenes knew that the town of Alexandria was located about 500 miles north of a town that was closer to the equator. Go ahead and read this. You guys can read. Okay, so when the sun is directly overhead of Cyan, a meter stick has no shadow, right? Makes sense. Directly ahead, you have no shadow, but somewhere else an object would have a shadow because it'll throw off the angle. So, a meter stick in Alexandria would have a shadow, right? I mean, this just makes sense. I threw my voice partially out this weekend. So, and we assume that the sun's rays are straight lines, right? So, precise data wasn't really available back then, right? Like, measurement tools were a bit more clunky, and it's the sun, and these cities are really far apart, and we don't have Google Maps. So what they ended up figuring out was about 500 miles from Cyan to Alexandria on the surface, right? Walking on the curvature of the Earth. How can we use this to figure out the radius of the Earth?
Part of the diameter, so we just calculate things. Calculate like.
Well, if you find the angle,
Find the angle, and then
you find the angle.
Talk with each other. You're not
Face each other.
Well,
find
if
the
you
angle, and
the
then
angle,
you find how much of the circle that is.
And
And then, you find the
Try it.
circle. and
Don't
then-
just talk, man. Try it.
Oh, okay.
Oh, but at least I'm talking. Gosh.
Well, it's a long shadow. Actually, never mind. I thought it said meters. Millimeters.
It's 6, 7, now.
So, we're going to have to back up here and get some information. I'm trying to make this fast, but at the same time not help you guys way too much. Before we can calculate this, I think a lot of you guys said we need this, right? Well, if my smartboard was anywhere close to right. So we're going to work with this triangle up here. Now, obviously not to scale, right? But this is our meter stick. And if we have parallel lines, right, the sun is casting what we're going to assume to be parallel lines, then this line and that line, very off kilter on my smartboard, are parallel. What kind of angle relationship do we have?
Well, we have an alternate
parallel, and then
in
that
Transversal.
called, yes.
So we have alternate interior, right? If you can figure out this angle, you know that angle.
Well, how do we figure out that?
Well, what is this length?
1 meter.
1 meter.
Which is
And if we assume that it is perpendicular to the Earth, that's a right angle. On this tiny little portion, because come on, we're talking about a meter stick, we're going to act as if the Earth is flat, right? Because it's a very small section of the Earth. So what we actually do is take a line tangent to the circle. So we're not saying the Earth is flat, but we're saying at that portion we look at the tangent line. So we have a triangle that's essentially 1 meter tall, right? We don't know how far. We know this is a 90. We don't know this. That would be great. We don't really care about that though.
That's a meter stick. Wait, so
What else do we know?
we know the length of the short It's
Wait, so we don't know.
0.127.
Ooh. So we could do that, or a meter stick is 1,000 millimeters, right? So if they reference millimeters, we could do 1,000 and 127. Solve the trig for that triangle to determine what this angle is.
You said we didn't have to use calculator.
You don't need graphing calculators.
You hand me that calculator.
You're not slick.
My calculator, what? My calculator.
Calculator.
Can you give me one calculator? I don't know what batteries are. Calculator.
Now we're using one of these.
Okay, yeah.
Oh.
Children
I
calculator.
forgot that I have one more because they only needed 4.
Fine.
Wait, Mr. Hudson, so the distance between Cheyenne and Alexandria is irrelevant.
No, not yet.
Not irrelevant right now, unnecessary. Right now, we're just working with this triangle up by Alexandria. You know the shadow was 127 millimeters long, so about 1/10 of your meter stick, just
Oh, I
over.
got the angle.
The height of that triangle was a meter, so 1,000 millimeters. And that triangle right there will tell us the angle that the sun creates in this corner up here, which is this corner. Just when you turn. That being alternate interior with this angle, what'd you get? Like 7?
Yeah, 7.2.
Should
I got
be
7.2.
Oh, I did 100, not 1,000.
7.238. Approximately. So check. You should get approximately 7.238 because we have the opposite and the adjacent. So tangent of that theta equals 127 over 1,000, right? TOA, opposite over adjacent. Inverse tangent, 127 over 1,000.
So that means that the interior angle is 0.2.
So this is 7.23. And guys, this was really, really, really basic math back then. Because now, what are you setting up?
Yeah, GLA, like.
A proportion. You know, a proportional relationship. GLA, yeah, Global Language Arts.
Oh.
So yeah, things always change. Well, you know that.
means they're weird.
Don't be upset. So, what proportion are you setting up?
60 divided by 7.23.
Okay, sure, or, I mean, that's totally fine. Like, sorry, that sounded, so sure, in my mind, I think the part that I have over the entire, sorry, not yet, and then the part that we have from Cyan to Alexandria, sorry, not 5,500, right? Yeah, 500 miles?
Yeah.
If we find a multiplying factor, so Gunner, if I don't know how to multiply, how do I figure out the multiplying factor?
Hold on, what?
If I don't know how to do that multiplication, how do we figure out what factor does the multiplication? If you don't know how to multiply, divide backwards. Okay. So, if I don't, now we could always cross multiply. Cross multiplication always works, but I want you guys to be familiar with multiple ways to solve these proportions. If I do 500 divided by 7.238, that gives me my scale factor. Yeah, I forget what the scale factor is. $24,800. Well, not the scale factor, but I think this comes out to be. Please try to get this on your own. Do not just copy down what I have. 816.
I just did 360 divided by 7.
I
That's
did.
my 2.
Yeah, so if we cross multiplied, you'd end up with 500 times 360 equals 7.238x. Snap, what'd you get? 24, 816. No, he still doesn't have the radius, right? That's the circumference. And we can work it backwards in
Divide by pi. Oh,
Wait, what do you do?
you divide by pi and then you divide by 2.
So that's your circumference.
The pi.
Oh, okay.
So if he wanted to know the distance of the radius or the diameter or whatever else, he can then work it from there.
So that's 3,958.08.
So this leads us to a very interesting conclusion. The portion of the interior angle, that center angle, right? However much this is, how does that relate to the arc we're talking about? The portion of the angle. Hey, so Ava's got something really prolific over here, like really deep, important, correct. Say that again, a little louder.
Well, that ratio between that angle of 360 is the same ratio as the arc to the circumference.
So we talk about arc measures in degrees, like we've done before. The arc measure.
Isn't it always because the central angle is always equivalent to the arc measure?
So exactly what we're trying to get from 622, 1022, sorry, too many things in my head, is that the central angle of a circle will have the same measure as the arc.
Isn't like the other when the angle's like farther in, isn't it like half of the arc?
Well, ask yourself, what if, and this is what mathematicians deal with, what if this went like that? What would this angle then be able to be? Well, we can figure this out, and we're about to figure it. Yeah, I know, there's no connect right. We can and will figure this out, and we're going to work a little bit quickly here now.
Yeah.
Jump straight out of my hand.
Yes, it did.
Yeah. Get used to this.
We're going to skip a lot here.
I was skipping 63.
Oh my god, get out.
Here's an interesting mathematical proof. Angles F, G, and H all inscribe the same arc. Angle F,
Oh
angle
yeah,
G,
because they're all part of the
angle H.
R dot G. They are all part of J.
F, G, and H all
JK, it's not
connect to arc JK.
Yeah.
Right? F's angle opens to there, G's angle opens to
Oh,
there,
yeah.
H's angle opens to there. What were you gonna question?
Does that mean that the angle is the same?
No.
Tell me, what do you think?
They're all.
Why wouldn't you?
I don't know.
Because
In different spots.
you could have it like an equilateral triangle. Oh, that's not. Never mind.
Like, this is a different angle if they're opening up these 2 points than this. Like,
Is it?
Yes.
so.
Okay.
That. Wait, is it?
Yes.
Wait, dude, this is like. It's just rotating around like.
Ava's flipping me off, dude.
Yeah, and we're like.
You're not. She's not actually.
I did this!
No.
But still.
Jenny, you take me so literally.
So, like, it would go like
I
that.
think it's called the ice cream and cookie.
All right, now that we've had some nice questioning,
Okay, so my question too.
so the measure of any inscribed angle is half the central. So if our arc over there is 118 degrees, what would our x value here be? And I do apologize that we're not doing as much like discovery type learning with this stuff. We just have some things to cover. X here would turn into, and again, these are degrees because they're talking about how much of the arc it is.
Ah.
Now, if you want to see a proof, excuse me, of why this works, we can make right triangles inside circles. Right, so if I open, say I have a point here, well, I do have a point here, but say I look at that point there and I look at this angle opening, I can then add a chord and make this a right angle, or make it a right triangle. If this is 78 degrees,
That's 12 degrees.
that's 12,
It doesn't look like 12.
which means Z would be
6 degrees. Wait, no, it's 24.
double
And Y would
Oh,
equal. What's 78 times 2? Do that and you had some. 150, 80, 100.
It's 100.
I'm just trying to become cool.
this right there proves why that happens. So we would have started this lesson by talking really in depth about what a semicircle is and how it's half the circle and it's inscribing half the arc. And if we put a triangle inside creating a semicircle like we've done here, what does that actually make? Like what relationships? And we take half the circle on the one side and then the other two angles that we have that add up to 90 degrees are complementary pair. They get the other half of the circle, and this will prove us to have the arcs being twice the inscribed angle. Now be careful, central angle versus inscribed angle. Central coming from the middle, right, from the center. Inscribed, scribed on the circle. So, if this angle is 56, and this y goes to the same end points, yeah, x must be 56, because from the central angle it's the same, which means the inscribed angle then must be 28.
Okay, wait, is the Y like that part of the
Wait,
triangle?
The y is
No,
this
no.
angle.
On E.
Oh, E? Y is this angle.
Oh.
Oh.
So, what is x?
114. And
Is it
would Y
central?
be 100? No, Y would be 57.
Same endpoints, right? So Jenny's recognizing that x Sorry, I'm trying to anticipate the offness of my board. As those endpoints. Y, same endpoints. However, Y is inscribed as opposed to central.
Y statement.
Boo!
So, how big would Y be? What is it?
66.
Yeah, 66. Wait, 67, right?
What?
57.
What?
I was about to, something like we did not cut in half correctly.
Yeah, I don't know.
But now I'm writing backwards. Stop.
37.
Half of the inscribed arc. Okay, your inscribed angle's half of the arc. Here. So, hold up. F is the deepest question here that we gotta look at. If this is 28, what does that make X? 56, okay.
And then Y would be 28. Yeah.
And then Y is 28.
Y.
Oh my gosh, no, stop.
But then, and we'll extend this here in the next lesson that we're about to jump into. What do we know about these two angles? They're equal. But what about these arcs?
No, it's
They're
not
not.
the center, so it doesn't.
Yeah, that's not on the center.
They're similar triangles.
Similar triangle.
Yeah.
I thought you said arc.
Yeah, they
Why?
Because they all have the same angle
Angle.
measures, but not the same length.
How do you think that?
Because they have the
Because
same
you
angle
know
measures.
that those two are.
Because you have the vertical
radius
angle.
of 28.
Hold on, we're all talking at the same time.
It looks like
Okay, give me one. Jenny was the first person
You
to
have
say
the
that.
vertical
something.
angles and you have the 20. So that
But-
means the last angle must be.
This 28 degrees. This 28 degrees. Right? They're inscribing to the same arc. This, whatever was left over, and this, whatever was left over, inscribing to the same arc. So when we have intersecting chords, guys, there's 7 chords. Up here is what matters. When we have intersecting chords, we create similar triangles. Here's all of
We're
your
gonna do it
important
tomorrow,
info.
so.
Minor arc versus major arc. Minor arc is the small one made by the angle. Major arc is
They're
obviously
similar.
the big one, the rest of it.
What if they?
A chord, straight line across the circle, right? We
What
know
if they're congruent?
then there's arcs. And actually, then they're just semicircles. It has to be. All right. So, this is a lesson where we start deeply talking about what is a semicircle. We're gonna skip this.
the lesson.
No, that question. So if we look at this inscribed quadrilateral, right? This polygon, it's obviously a quadrilateral.
Wait. So we're. 10.2.
We're on 75 now. Okay, so we know a lot of things at this point. Go ahead and draw this in your notes. Draw the circle in your notes. What could we say first to start to just like piece together some information? What could we say first?
It's.
If my 100 degrees,
So that's
Yeah, oh my God.
it. The arc from B to D. That's
and we could actually say BD with the arc. Just put a little arc above it. Obviously, that's major arc BD. Which, okay, means minor arc BD must be the leftover, right? Because a major arc and a minor arc have to sum to 160. Yeah, sorry. This is my brain. You're good. So, what can I do now?
Oh, we know that X is 80.
Do we all see how we know that X is 80? If this arc is 160, which is what we just said because they have that relationship, this must be 80.
Is that what we're trying to do in this problem?
Yeah, but there is more, which we'll get to.
This is kind of fun, but like when you get to proving these stuff, it's so.
Don't make this more sad.
I mean, this kind of like I like this, but like.
Makes me like math that
Is
Well,
correct.
that is that, so you gotta hold some kind of.
I think so. Because at least in this, the that up to 180s and the other one that up to 180s.
So this question that you can only really see half of it is what's her face asks. Wait, I think opposite angles inscribed in a circle, like an inscribed polygon or an inside quadrilateral, are going to be supplementary.
I think that's correct.
It's an interesting conjecture. Let's test that as we go.
Yeah.
At least that one's correct.
We have now intersecting chords. Remember what we said about intersecting chords, although they don't make triangles here.
Ice cream cones.
I'm sorry. Look, I've not eaten lunch yet, so if we can stop talking about food, that would be fantastic. Thank you. We had testing this morning, and I had no break. So, try this. What can we do? What can we figure out?
I have to make another perfect term. I found this way where you can draw like a circle really well.
Unnecessary.
What's angle B? Oh, never mind.
It's too fat.
Your circle shape.
That's not really a shape.
That's bad.
That's really bad. I don't think I can do dotted lines. Maybe that's my head.
Yeah, that's fine.
Oh, this is for that.
Just get a ruler.
So,
Know the length of the.
yeah, BE is 6, DE is 8, EA is 4. So we know they're similar, but how do they, like, what parts are going to relate to each other?
Oh, well, ACE is half of DBT.
Oh, hold on. So angle B, right, opens up that one. What would it relate to? Angle C.
Because they're all they're no, they're not. I mean,
Well, B
they're
and
the
C.
same. They're the same.
Not even the triangles.
No. I mean, it's kind of obvious.
And then angle A would relate with angle D. How are these triangles related?
They're similar.
Well, okay, yes, but
0.5.
Oh, you
scale factor
0.5 or
of either 0.5 or 2. So, if we're trying to figure out EC, it must be 3.
Oh, that is.
questions?
My friend has a grade of 95 in his class, but that's only because he doesn't turn in his homework. But he gets 100% on every test, and I
Not a
don't.
good thing to do.
He doesn't even do his homework, and I don't understand.
All right, so if the radius of circle P is 6 units, minor arc LM 150. See what you can figure out here. Yeah, make it close at least.
Basically, you just put your like thumb in the middle of the paper. You put your pencil at a certain distance, and you just do this. It's like your own. I don't know, but it's kind of off.
I used to just carry a quarter with me. Trace a quarter.
Wouldn't that be rough, though? Like, 'cause it's not.
Not really, because the
What's
pencil
a
just.
circle?
And back in those days, there were actually payphones around.
See, look, I did this with my hand and my pencil.
Even back in those days.
When I was in middle school, I didn't have a cell phone, and there were payphones multiple places around town.
That's not
My
really
bike,
surprising.
almost everywhere. I rode my bike about everywhere. I got in trouble once because I rode across the bridge, which was a highway, and went over Lake Park. And my mom's friend saw me at Lake Park. Oh, it's on Lake over the park. I wasn't allowed to ride on the highway.
Well, I mean,
No one's allowed to legal.
There's a sidewalk.
No, there's
Like,
a there's
oh,
an area
okay.
dedicated to it.
But my mom, who's crazy,
I'm planning to walk.
You know, she has good intentions.
She does have good intentions.
Walk over to
She's the reason I'm
her-
alive right now. Like, still alive. Obviously, with the original reason.
her part. That would be so much fun.
What else should I draw here? Somebody who hasn't really contributed much today. Anyone want to jump in? Ethan or Chris or Ryan or Colin or Gia?
Yeah.
Even.
Colin. No. Yeah, Colin.
Ooh, draw a line from P to L. Okay. So that'll be sick. Ooh. Okay, so now we've created an isosceles, and from there, okay, half of 150, is that what you're saying? So that gives me, oh yeah.
Kool-Aid.
Oh, God.
And then, now hold up. My challenge to you is find out how long LM is. LM. LM. It's not earbud. It's a sync cable. What are we going to do here, Colin? How are we going to solve this?
So this was nice sauce. Wait, never mind.
It's not
I
sausage.
missed math. Well, I know, but I missed math.
Okay, then fix it. Grab your pencil and fix it. What can I do here? Or you can keep going. You want-
You can do trig.
But I can't do trig with an isosceles.
Yeah, but you can do
Cut
trig
it in
with the
half.
right triangle. You can cut it in half.
So
and
we
you
take
double it.
the isosceles, cut it in half. You make a right triangle with half your isosceles, so you know that's 6, and this is... No, it's not.
37.5.
It's half of 75.
So you want to
Because
find
what we have just done is dropped a line right here.
So you got it.
Who what?
No, I got 15.126.
For what?
For the
doesn't make sense because the hypotenuse has to be the longest.
Wait, what did you get? 15. I got 3.6. I have a double for like just
All right,
like
you
that
got
one.
my
Not the
tangent.
hypotenuse.
I did
like
double
the
A.
LM.
I got 7.
I know. This can't be longer than 6.
Yeah, okay, got it.
The half of your chord, this, can't be longer than 6. Set up your tangent, right? I have, what side do you have here? Abel, what side do you have?
Excuse the interruption. Could I please have Joe Suddendorf to the office? Joe?
You have the hypotenuse. You're trying to solve the opposite. We use
I did do it wrong.
You got
sine.
7.3.
Sine of 37.5 is going to equal x over 6, opposite over hypotenuse. So 6 times the sine of 37.5.
You get 3.65, and you multiply that by 2, and you get 7.30. Yeah, 5.37.48.
I have a trick problem here.
See, now you guys wouldn't get the joke if I said, like, that all we need to do is get jiggy or get triggy with it.
That's clever. We
The,
know
do you know the song Getting Jiggy with It?
Yes, I know what that song
I didn't know if that was still like a thing.
No.
Okay, Will Smith is never not a thing. Alright, any questions on this? Any questions on this? Are we good, Jen? You're just sitting there valid pass line. Alright, let's try this. Real quick, we only got a couple minutes left. I'm gonna pick up some more problems.
Flip the page.
Hey, let's do this. For your homework tonight, for 10.2.2 and 10.2.3, let's just say pick 6 problems that you think will benefit you for the test. So, because we're out of, well, I can look at the schedule. I think we're out
From
of
both
time.
homework.
Well, your normal schedule today, right?
Yeah.
Yeah, then we're just out of time. So, please solve at least 3 circle problems. But pick 6 problems from the 2 different problem sets.
In total, or?
Yeah, just 6 problems. I think there's like 5 or 6 in each of them. So just pick 6 total that will benefit you for test prep so that we can go over them tomorrow if you need. Do at least 3 circle problems. And that is it. Have a great day, guys.